Okay, I guess that's my cue. Wow, what an introduction. So yeah, I'm just gonna talk fairly quickly, or try to be quick, about the current state of automating browsers using natural languages, specifically for the purposes of writing end-to-end tests. Right. So just real quick introduction. What is natural language? It is basically the ability for us to write plain English for LLMs to perform tasks. And often this is expressing what it is you want, not necessarily giving all the details about how to achieve it. And really, like this is very enticing. This could yield some really big wins, whether it's for ease of use, right? It's great for non-developers or junior devs, or even people that enjoyed Cucumber, because ultimately, it avoids having to really understand all of the app implementation. And probably the most powerful capability of it that I would say is, by using natural language effectively, we insulate our tests from being brittle, right? So we have the ability to get self-healing and insulate ourselves from the DOM that is always changing with the application, because it's effectively decoupling the test code from the app code. There's also benefits like portability. So being able to write your instructions in plain English allows for greater portability and integration to other systems. So like you could basically ingest, export, or migrate those instructions between systems. But with that said, pulling that off is, especially in the world of automated testing, is definitely no easy feat. There are several significant downsides and hurdles to really any viable solution that you would have to overcome. So, first off, like if you're used to writing code, code is free to run, but having every individual step translated by AI is definitely not free. And as a result of that, because you're using AI, quite frequently you will see the run times of performance just absolutely balloon and run orders of magnitude slower, uh, because you're sort of translating between English or whatever your natural language is into code that adds a layer of obfuscation, right, or indirection relative to what you would be writing with code. So debugging is hard. And of course, as we're all familiar with, like, you have to be able to overcome the reliability issues with LLMs, because after all, if the goal is writing test code, and test code is, you can almost think of it as like a scientific instrument. It's giving you feedback on how well things are working. You need that to be accurate for that to have any value at all. And so I just want to quickly, level set on a few things, right? So if your first reaction is something like, well, why can't we just use Cursor or ChatGPT? Maybe, before some of the newest things like computer use tools and MCP. And really, that is because like you would not be able to have automatic self-healing, because the inputs need to be checked in, and they need to be actually evaluated at runtime. Like if you only stored the outputs, then really you'd just be storing the same thing as code today. And just a quick, simple illustration by inputs and outputs, like when we classically work with Cursor, right, we're giving it inputs. So, hey, Cursor, create me two button components. Then Cursor hands back the outputs, the code that produces that. And then you may interact with it, right? You may tell it to update that code, and it's going to go ahead and update those outputs. But ultimately, only the outputs get checked into source control, right? That is the only thing that ends up getting checked in. That's the only thing that goes to production. The inputs, the set of instructions that produce those outputs, are dead and they are gone. And therefore, if you just used a process like this, that would effectively just be like a one-time conversion, and you would not get self-healing as a result of it. So now, that was all before we had some of the latest capabilities, right? And I'm sure you're also wondering, all right, well, isn't this a solved problem, right? Can't we just use MCP, or can't we just use tools? Also, there's been all these crazy updates lately. There are major players getting in this game. And really, that is because natural language does give us a huge amount of benefits that actually can be used to solve lots of different problems, not just the ones with automated testing. And so in this talk, like I just wanted to say, hey, over the last few months, this is something that's been near and dear to me. We've been rolling up our sleeves and basically evaluating, looking at the landscape, understanding it, and trying to see, would we be able to utilize this to basically put this together. And so I just wanted to go through and share a bit of it, a bit of updates with what we've learned and what we see based on the current state of the art of what's out there right now. So I'm first going to basically be talking about all the latest like AI specialized browser agents. Most notably, OpenAI is one of the latest players. They released Operator, and they're building Operator to be a natural language interface to browse and take action on the web, right? All of these are commercial tools. They all require subscriptions, but we paid for it and evaluated it so you don't have to. So if you haven't seen these, you're about to see these. Now, one of the first things I want to call out is like when we go to Operator, and much like all of these, you will notice, basically these tasks written, but they are not for test automation. They are general purpose web tasks. And these kinds of instructions are actually extremely ambiguous. They are very high level, which is, of course, extremely valid for general purpose tasks that you want the AI to accomplish. But they're actually really not great for testing for a number of reasons that I will try to make evident throughout this talk. And to illustrate and kind of give us like a single point of comparison and keep things as apples to apples as possible, I'm actually going to be providing these steps to all of the different platforms out there right now, because these are very simple and sort of self-describing. They are much less ambiguous. And the goal here is that we are going to get a better apples to apples comparison about how all these different services handle this. If we introduce non-deterministic or ambiguous instructions, then things would be, I mean, even if you just gave the same service and ran it again, it's going to likely do different things. That's going to create way too much noise and make a proper comparison that much more difficult. So this is what we're going to use for the rest of this talk. So I've got a video playing here, and so this is Operator. I've given it the instructions, and I have a little timer going here. Notice it is counting very fast because all these steps are really slow. And so you can actually see what the sort of real wall clock time is. But after a minute, we can see that Operator has individually performed all these steps. We have some nice UI tools here, the ability to kind of go back and look at the history and inspect what's happening. So that is Operator. It took about a minute, but it performed the steps correctly. Next, we have Mariner. You'll also see it's the same sort of thing as Operator. It's not focused on automated testing. Of course, it's very general purpose web tasks, right? Those are all their examples here. And if we watch that and give it the exact same steps and speed it up, once it prepares our session, we can see it's like same interface, right? It's telling us what it's doing. We don't have the same capabilities Operator, like we can't go back and look at individual steps. But right off the bat, we actually see that it's done the wrong thing. And even though these instructions are fairly simple, it still struggles with them. But really, the most important thing I want to call out here is that because general purpose tools like this, in fact, let me just play this again and stop. They are all aiming at effectively like performing the steps and trying to recover from them. In other words, like they will attempt to find multiple pathways to accomplish your goal. And therein lies one of the core challenges with using that approach for automated testing. It's completely valid for, tasks, if you're trying to check out or buy something on a public website, you don't care how it works or what it does, as long as it reaches the same outcome. but testing is fundamentally different. Uh, the entire purpose, like if you have multiple pathways that have been coded and you need to ensure each one of those works, having something that is basically doubling back and potentially, applying mutations, it may not actually be safe. But the worst part of it is that the AI itself is effectively the judge of it, unless you're adding things in your code that assume it's on one, particular pathway. And therein lies like this natural tension between like what we're attempting to do with automated tests versus what these general purpose tools are effectively trying to solve, but for a totally different problem. Next one we'll look up is browser use. This is basically, the same as the others. The one thing I want to call out here is you'll notice it's relatively the same interface, but you'll see all of these marks, right? All of these like covered boxes. We also notice it takes about 2 minutes. It does pass, right? But it still takes 2 minutes. And the interesting thing I wanted to point out, let me just pause this video, is this is using a technique called set of marks. So if you've done or produced any solutions yourself, you may have come across this. Set of marks is basically a way of guiding, visually trained LLMs. You're basically annotating the most important bits. In this case, like they're just inserting those things into the DOM, then they're taking a screenshot, they're handing the screenshot off to the LLM. But that is one of the it's a very common technique. It works really well. It's just extremely slow relative to other strategies. For certain things, that is the best and only way to solve it. But there are also alternatives as well. Just pointing it out because that's one of the main reasons that it's slow. And I just thought this was really funny. Like I think this is actually GPT saying this, but after completing the task, it's like the ultimate task successfully completed. It is kind of the ultimate task. All right. One more we're going to look at is browser base. So browser base actually just recently put this out. This is using the computer use, the new APIs by OpenAI. So it's doing something similar to Operator. Works in similar way. You put in your steps, it's going to give you the individual output. There's really nothing too crazy about this. If I just kind of skip ahead, you can see it's slower than Operator, slower than browser use, but it does work, does complete the steps. Only Mariner basically failed to do these initial steps. But the other reason I'm showing this is because like the Kua from browser base is actually like one of their latest products, right? But they're the one existing before it, I think, is actually much better suited for automated testing. And so with this one, you can see it's definitely different. Like it's basically aimed at being integrated directly into your code. And they have this little playground product here and this new AI code gen feature where effectively you give it the natural language and it's going to convert it into code. And so I was using this where I give it the first step, and it does do this, but we can basically see like a preview of the code that it's generating, and we can actually see that like while it is interpreting the natural language, it's kind of like the early days of like Cursor. What I was saying is that it wouldn't actually be processing the natural language every time, because this is like a one-time conversion to automated test code. But this particular product is definitely aimed at supporting automated testing as opposed to just being like a general task runner for the web. So anyway, I put that one in, and then I write the next one, the next step, and it attempts to do this, but immediately it fails. It's like it finds two elements, right? Which is strange because they're the ones who produced that selector, right? It's like if you're gonna fail, don't produce a selector that's gonna find two elements. And and then I just, even though it failed on this step, I just gave it the rest of the steps, and I actually noticed, like, even though the app is like hung right now, it's not performing those steps, and yet it's still like producing the code for these, which is also strange because I mean that's the same problem with like, before MCP and tools. If you ask Cursor like how to, if you gave it inputs like, hey, go test my app, unless it's actually running in the browser, it has no idea what it's going to see, and so anything it suggests is just going to be hallucinations. And I find it strange that, like, well, I mean, they have the app, but they're not synchronizing the steps, right? So they're just hallucinating the same way that like Cursor would if it doesn't have any idea what's in here. Like it's just writing in code, but it's not writing the code as a result of running the steps, which is a little strange. Kind of uh, doesn't really make a whole lot of sense relative to the position they're in. So uh, I was going to say, like, even though this broke, uh, I, I don't want this to come off like I'm just putting down other services, because this is actually an incredibly difficult problem to solve. And I just want to say, like, actually, browser base is really good. Um, this isn't even really like the classic use of it, and I want to call that out and totally be fair to them. Like, they actually have, unlike the other services which are just focused on general task, management. Browserbase has actually a ton of features that is just around test automation. So they have, all of these capabilities, way more features than what you'd see from the latest players. I just wanted to show this off here, and I was using the playground and like a beta feature, and so that's not like the classic usage of it. So I did also just want to show their docs, right? As in, like, you're really supposed to use it in this way, right? And if you were interested in using an actual service to do this for automated testing, even though your first thought is going to be more about like the mechanics around translating the natural language, because that is hard enough by itself. But actually, to support this, you would need a ton of other features as well. Like, all of those were spinning up browsers in a VM. You don't have direct access to it. It may not even be able to connect to localhost. There's just a huge amount of problems, right? And I'm just calling out, like, their service is aiming at providing that level of support and features. And as we see things like Operator or Mariner or other products from big players evolve, for it to work with automated testing, it would need to not just solve the NL to actions problem, but it would also have to support things in order to actually be useful. So I'm just calling that out, right? And they've done like a really great job. So coming back here, as we sort of evaluate general purpose agents, we see uh, most could perform it. Uh, the runtimes are still pretty significant. I wouldn't say this is like a non-starter, but it's definitely a hurdle. And what we also have looked at, and I'm not going to include these competitors' names, but basically what I'm trying to frame is that, you know even though I expect these services to evolve tremendously, they're brand new. Not putting them down by any means. This is a really hard problem. I'm really just saying that what they are geared to do is more of this general task-based type stuff. And there is natural tension between the way that those will always work relative to the needs of automated testing. And that's besides the fact that you need a lot of other uh, aspects of support to really solve the problem. And turning our attention to existing incumbents in the space, like, I've sort of classified them differently. They're more like automated testing agents. Uh, Even though I'm not going to name these by name, I just want to call out, like, none of these are new. They're all big incumbents. You could easily find them. Um, Typically, they have integrated the natural language as part of like a low code, no code solution. They're not trying to be general tasks, but they're also not trying to be as low level where it actually outputs the test code. They're kind of somewhere in between. And I think it's just kind of interesting to look at their results. They have all of the other supporting infrastructure. And if we kind of look at these results, we can see that, competitor, company number one here, they have, like, still these incredibly high runtimes, but we start to see this new notion here that we don't see show up, which is like they sort of separate out like what is the initial run versus like the cached run. And in this case, this company doesn't have it. I'm not sure why. This third one, even though it struggled with these same steps, it totally hallucinated. We had to like fix it. We do see something uh, that is getting much faster relative. So this basically kind of signals what sort of the opportunity here really looks like. And certainly I probably wouldn't be getting up here and talking about this if it was just sort of a report and analysis. I just wanted to basically share some of our findings. This is kind of like the state of the art relative to a few different lenses to look through it. And I find this opportunity pretty compelling, pretty interesting. Like, it is a hard problem. I think it can be solved, and in solving it, you would be able to, differentiate yourself and create, compelling amounts of value, right? So this is something that we have been exploring for the last few months. I've personally been doing and enjoying, and I just want to share kind of like a sneak peek of something that we've been working on, behind the scenes. So we haven't announced or really even talked about it all. And so, with us, we're obviously a testing framework, and you're going to write your tests in the code itself. So the most natural place to basically put natural language is definitely the code, right? So this is just an example code. You just write a little prompt here. This is the same steps that we've been using and testing with all of those various providers. And if we actually, look at how Cypress is going to handle this. So this is executing the prompt. This is the very first run. So I'll give you a little hint. There's definitely an element of caching here, but it just finished, and it finished in 13, 14 seconds. Already dramatically better on a relative, apples to apples basis, right? And then when we run this again, I think is where the real magic happens, because effectively this time is virtually, it's like 95% as fast as actually not using NLP at all, but it is still using NLP. And this to me, this is where it starts to get exciting. And it took quite a lot to basically pull this off. And I would say I would need a lot more time to go into those details, and I'm happy to. But effectively, we are using some of the same patterns that you would see in the other services, but at the end of the day, like, we've effectively reduced the LLM's responsibility to that which it is actually best positioned for, while maintaining and retaining sort of our strengths as the driver. And we have sort of changed that relationship pretty dramatically relative to some of the other incumbents. And that puts us in a position to basically strike a balance between all of those different attributes, right? Like, reliability and performance are kind of like negatively correlated. You improve reliability, you drop performance, and vice versa. So like harmonizing all of those things together is definitely like an art as much as it is a science. And I just ran it again just to show another run, right? It's pretty much going to be that every single time. So kind of coming back to our stats here, this is the actual data, and that's what it looks like on a relative basis. There's some other cool little features. Exit full screen. I don't see it going full screen. Okay. So one of them is basically, I talked about how, like, whenever you have this abstraction, indirection, right, wrapping all of these things, that makes debugging a lot harder. And, by putting it in the code and kind of using what we already have, like, we've normalized all of this. So like we see like the prompt, there's 9 steps, and basically it's breaking out each individual step. And it's, giving you the ability, all the classic time travel bits. And if we kind of just skip forward here, like, we can see, within here, we actually have the resolved Cypress commands. Like, we didn't write those. That's what it evaluated to. So effectively, you can see everything that you'd expect. So you're not disconnected from what the actual natural language is producing. And in addition to that, one of the other important things was basically giving you the ability to not just see the code, but also, potentially eject it. And by ejection, it's sort of like, I don't care. It's like if you want it to be a one-time thing and convert everything, fine. Like that works. If you want to inspect it so that you can alter it or fix something or see what it's doing, that is also cool. You'll lose the benefit of self-healing, but that is your choice. So I see this as like, well, you can keep it as natural language, and as your application evolves, if that is important to you, keep it in that form. Uh, you won't really be paying the performance cost, or if you want to just eject it, you can always basically go back the other way and get out exactly what it's putting in. And so then that gives you the choice to basically have the best of both worlds. Some other cool things like you know this goes to deeper principles about determinism and everything else. Like if you give the LLM instructions where it has multiple options, we kind of already saw that problem. That's kind of a different class of problems, right? But we're handling it in a similar way. This is pretty simple. This is basically just saying like, what happens if you basically don't give the LLM enough instructions? So like I literally just take away the actual values that it has. Uh, it's really, or at least this is like a quick example where like we'll catch all of those situations. We'll bubble them up to you. In this case, it's saying like these steps failed, there was missing information. You would get different errors depending on what happened, and basically right within the interface, you can just like fix it, submit it, and and then it runs again. Um, and let's see, last thing, I'm almost done. It's just because this is integrated into the code, there's not like NL is not seen as something different. Like you just write your normal test code. You can write stuff before and after it. It's all equivalent. It all works exactly the same way. There's no sort of gotchas or weird ergonomics around it. There's other nice things like passing parameters. So you don't have to do like string concatenation or weird stuff like that. And there's also, support for assertions. So that you can effectively express the same types of things that you would normally express with regular Cypress code. This has been probably over in the lightning talk. I apologize. That was all I had. I was basically going to say that look at if you're curious about this or you're interested, want to be one of the first ones to try it, go to this link. You can get early access. We're expecting to have this release as an experimental feature next month. So if you're curious, join and you can get be one of the first ones to get your hands on it. That is all I have for today. Thank you for coming to my talk.
Hi, thank you very much for your talk. It was lovely having you here. We got quite a few questions from the audience, but we don't have a lot of time to go through all of them. Maybe the folks that ask those questions can find you on socials, and maybe you could answer there, or you could stay a little bit on the chat to answer some questions there. But I will start with having AI write the test at runtime seems sketchy for reliable automated tests. E2E tests are already flaky for many reasons. Why would adding another method of breaking independency help?
Well, I mean, of course it wouldn't help if that's what happened. I mean, the whole goal is like you would have to be able to do it, and this is where I did not even come close to getting into all the details. There is a need to balance the ease of use with natural language with enough strict adherence. I talked about how like you don't want the AI basically like doing different paths than what you had in mind and potentially coming up with false positives, because at the end of the day, like you still need the same assertions and guards and everything else, because when it encounters a failure, it will never know the difference between like a real failure or a mistake it made. So like it just goes back to like of course that will happen. It requires absolute sort of uh, synchronization across the board and all of the rules to basically to be able to fulfill that contract properly, such that you would get the ability to have broader ease of use, but without those trade-offs. And that's what makes it a hard problem.
Thank
But
you
it is
for this
possible to
nice
do.
answer. We have one more question. How do you see AI testing evolving to become more practical?
How do I see it evolving to become more practical? Um, you know, I don't know. I would say that the pace of how fast everything has been evolving, I would say, I'm not the best person to even answer that question. I don't think I could have predicted as much as it's evolved and how fast it's changed. Um, yeah, I don't know. I've got decades of computer science and testing experience, and I have like 6 months of AI experience. So I'm I'm not an expert there.
Thank you very much. I think that we have maybe time for one more question. Let's get this one. What's your approach to debugging when AI automation fails? I think you got a lot of tough questions.
Oh no, I mean this one. I would say you try to make it. You reduce the indirection. You reduce the obfuscation so as much as possible, such that effectively you crush all of that out, so that it then becomes the answer to that is whatever the answer is for just normal debugging normal test code failures, right? So making the translations very apparent. Making it such that like when it basically does reliable tasks, it's going to use those same pathways again unless something actually changed. Surfacing those changes, there's tons of ergonomics that you can do to basically improve that. You just have to be incredibly intentional, and it's one of those things that I think it has to be sort of synchronized across every area to be solved really well. So like if you're building a system to be able to do that, like those are all things that you would have to account for in order to produce that type of experience.
Thank you very much. Thank you for having this talk with us, and I hope to see you soon.
All right, thank you.